Algebra 1, Arkansas Standard, SEI 2, AI 6. Solve problems involving direct variation and indirect variation to model rates of change. Vocabulary: direct variation, a linear function in the form of y equals kx, where k is the constant of variation and k is not equal to 0. The constant of variation k is equal to the ratio y over x. Inverse variation, a function that can be written in the form xy equals k or y equals k over x. The product of the quantities remains constant, so as one quantity increases, the other decreases. Example 1. Your score on the math test varies directly with the number of problems you answer correctly. Your score is 80 when you answer 20 questions correctly. What is the constant of variation? To find the constant of variation, we're going to put our information into the formula. Y is equal to kx. Y in this situation is equal to your score, which is 80. X in this situation is the number of questions that you answered correctly, which is 20. K is your constant of variation, and that's what we're looking for in this situation. So let's plug our values in. We have 80 is equal to k times 20. Now, to find the value of k, we need to solve the equation. So we're going to divide both sides by 20. And we find that k, our constant of variation, is equal to 4. And in this particular situation, it tells me each question is worth 4 points. Example 2. A recipe for 12 cupcakes calls for 2 teaspoons of vanilla. The number of cupcakes varies directly with the amount of vanilla that you use. How many cupcakes could you make if you had 8 teaspoons of vanilla? So we know that 12 cupcakes can be made if we have 2 teaspoons of vanilla. What I would like to know is how many cupcakes can I make with 8 teaspoons of vanilla? So I'm going to cross multiply. 8 times 12 is 96, and 2 times y is 2y. Then I'll divide by 2, and y is 48. So I can make 48 cupcakes if I have 8 teaspoons of vanilla. Example 3 says, for the table below, use the ratio y over x, the constant of variation, to tell whether y varies directly with x. If it does, write an equation. We're going to make another column here for that ratio of y over x. The first ordered pair, the ratio is -1 over 2. The second ordered pair is 1/4. The next is 3 over 6. And finally, 4.5 over 9. Now, I want to put each of these in simplest form. This one's in simplest form. This one's in simplest form. This one, 3 over 6, is equal to 1/2. And 4.5 over 9 is also equal to 1/2. For this to be a direct variation, each ratio would have to be equal to the same thing. Well, as you can see, I have -1/2, 1/4, and 1/2. So this is not a direct variation. So if it's not a direct variation, I can't write an equation. Example 4. For the table below, use the ratio y over x, constant of variation, to tell whether y varies directly with x. If it does, write an equation for the direct variation. So we're going to have another column. We're going to have a y over x column. For my first ordered pair, I have 4 over 8. Second ordered pair is negative 2 over negative 4. And the third ordered pair is 5 over 10. Now I need to go back and simplify each ratio. 4 over 8 simplifies to 1/2. Negative 2 over negative 4 simplifies to 1/2. And 5 over 10 simplifies to 1/2. So is this a direct variation? Yes. Its equation should be written in the form y equals kx. And if you have k, then you can write your equation. And what we've done each time here is we found the value of k. It's 1/2. So my equation is y equals 1/2 x.